start with the last seventh chapter, that is file handling in Python. Okay, so now all the programs till now what we have discussed in the past chapters, in all those programs the data which we are accepting is coming from the keyboard. That data is getting stored in your program variable. Then your program is reading the values from that variable, doing some calculation operations on it, producing the result, and the result is also stored in your memory variables, and from memory variable it is sent to the output device. But all these values which are kept in your program variables in memory, that exist till your program is running. The moment your program terminates, all the values are lost. Getting? So what I want to say is clear to you. Okay, all the programs which we have discussed till now in all the past 6 chapters, what we were doing, we were accepting the input from keyboard, and whatever input you are giving through the keyboard, that is getting stored in program variables, isn't it? So input coming from keyboard, whatever value you enter through the keyboard, that is getting stored in your primary memory, main memory. I hope you know it. It's volatile. It is not what permanent. It is volatile memory. Okay, it is ephemeral, you can say. Like the value in this memory persists till the power is on, or till your program is running. If the power is off or your program is terminated, so all the values from this primary memory are lost, isn't it? So in this primary memory, whatever data you have given from the keyboard is stored in the form of variables, right? And then whatever script you have in your memory is running, that script reads the values from this primary memory, that is from the variable, do some operation on it, and it produces some result. So this is your Python script. The script is reading the values from the variable, doing some calculations, decisions, whatever, and producing some result. But whatever result is produced, that is also kept in your primary memory in the form of variables. And then the values of that variables are sent to the monitor, that is to the output device, isn't it? But in this whole process, you can see the values which are there in these variables in the primary memory that exist till your program is running. The moment your program terminates, all the variables are lost. Means these values are lost. They won't exist, right? But the situation is that we want to keep these values. Now the requirement is like that. Now my requirement is that these all values I need to persist. Means all these values I have to keep it in some permanent storage. I want to make it persistent so that I'll be able to recall it anytime whenever I want in the future. That is my requirement. So actual my two requirements are there. One, I should be able to recall these values anytime whenever I want in the future. Getting? Means the moment program terminate, the values are lost, but I want that these values should persist for the future. Means in the future, if your program is off, machine off, again after some time you start your machine and you want to recall that values, so I should be able to recall the value. One requirement. And second, I should be able to do large amount of processing irrespective of the size of memory. Now your primary memory size, there is limitation because it is made up of very high speed logic, and therefore the cost is high. And as the cost is, obviously the speed is also high, but the cost is also high, and therefore you cannot put abundant size primary memory. Getting? Your primary memory cannot be of what? As your hard disk can be of 1 terabyte, so that much size primary memory it is impossible to put, because it will be too much costly, and the architecture of your computer also will become bulky if you put more primary memory chips. So in short, primary memory can process some fixed amount of data. But suppose your data is too large, which you want to process, which you cannot accommodate in primary memory. So then what? So obviously for that the solution is some secondary storage, not primary memory, some secondary memory. Okay, and on that secondary memory, the information whatever is kept will be in the form of files, because secondary memory is permanent memory. It is not a volatile, it's a non-volatile. Means though the power is off, the information is not lost, the energy is preserved, and whenever you want in the future you can recall. So now what I said, the limitations of this primary memory: one, it cannot persist the data for long time. The moment program terminate, the data from this primary memory is lost. One thing. And it cannot process abundant size data. Getting? Means if your data is too large, like for example in data analytics, like you have to process lakhs of data. So that lakhs of data, sorry, you cannot process in your primary memory, because the primary memory size limitations are there. Getting? So as I said, like for analytics purpose, like you have to fetch the data from the CSV file, and from that CSV file the data which is getting fetched is abundant, like it can be in lakhs of data. So that much amount of data you cannot load it in primary memory. Getting? So the two limitations are there. One, data lost as soon as the program is terminated, because it is kept in primary memory, that is volatile. Volatile memories are, I hope you know it, that is RAM comes under volatile memory. The data exists till the power is on. Power off, everything is erased. So one limitation is in this whole model, whatever I said, the moment your program terminate, everything from the memory is lost. So data lost as soon as the program is terminated, because it is volatile memory. And second, cannot store large amount of data. Like if I want to process abundant size data, huge size data, so that abundant size data you cannot process in this primary memory. Getting? And obviously for that you need to go for some secondary storage. So our expectation is what? This problem to be overcome. Our expectation is we should be able to process huge amount of data, and second, our data should persist. Okay, our data should not get lost the moment program is terminated. We should be able to recall the data anytime, whenever we want in the future. Getting? So our expectation is should be able to store large amount of data. First of all, means we should be able to process the data which can be more than your primary memory size. Getting? So that is only possible by going to some secondary storage, where the secondary storage capacity is huge, and obviously on that secondary storage the information is kept in the form of files. But then you may say, like, how the files come in prime? So there internally virtual memory technique is followed. They come in pages, paging mechanism, page replacement technique. So I'll not go into internals of operating system policy. Here just remember, our requirement is we should be able to store large amount of data, one thing, and we should be able to recall the data anytime in the future. Getting? So anytime after 1 month, after 1 year, we should be able to recall that data whenever we want. Getting? And this is only possible if we go to secondary storage. Getting? Because on secondary storage the information is kept in some energy form. Now secondary storage, like if it is disk, so the information is kept in magnetic magnetic disk are there, and the energy is kept in magnetic energy. And then later through the transducers, the conversion of electric to magnetic, magnetic to electric, vice versa happens. If it is CD, so it is optical form, pits and pads, laser beams are bombarded, and then accordingly the information is kept. Anyway, the energy is stored, and then through the transducers the energy conversion take place, whatever. But to achieve this two expectation, obviously you have to go for secondary storage. But on secondary storage, how your information is logically kept, like in your primary memory, how the information is kept. In primary memory, information is always kept in which form? Variables. Yes or no? In primary memory, whenever you want to store information, some memory is reserved, you store the value in it, and to that memory some logical name is given, isn't it or no? In your primary memory, how do you keep information? In the form of variables. So what are variables? They are just the name given to some memory location. So some memory locations are reserved, to that memory location some name is given, and the value kept in that memory location can change. You can retrieve, you can store, but to those memory locations some logical name is given. Exact same technique on the secondary storage. Some blocks are reserved on your disk. On your disk some blocks are reserved, and to that block some logical name is given, and that is only called as file. Getting? So everything on this disk will be kept in the form of file. Okay, files stored on disk. Okay, and what is file? As I said, you can say file is a name given to some blocks on the disk which you have reserved to store the information. Means to store the information, to retrieve the information, some blocks are reserved on your disk. And how do you recognize that block? By some name, and that is only file. That simple. You can just make an analogy, like in primary memory you store the information in the form of variables, so on the secondary storage you store the information in the form of files. Like in primary memory some bytes are reserved, some name is given to it, and the value in that bytes keep changing. Exact same. On the disk some blocks are reserved. On that block you store the data, you read the data, but how do you recognize that block? By some name called as file. Getting? So you can say a file is a named place on the disk where your related data is kept. Getting clear? You can just relate like that. Okay, on the disk, in the variable, how the memory is reserved, and to that memory some name is given, and the value in that memory can be retrieved, modified. Okay, but to that memory what is given? Some name is given, some logical name. Exact same. Okay, on the disk blocks are reserved, data is getting stored in that block, but to that block what we give? Some name, and that is called as file. Getting? So I hope it is clear why there is a need of file. Is it right, all of you?
Yes.
Okay. So the basic idea you got it. Why do we need file? So as I said, till now whatever programs we have dealt with, okay, in all the past chapter, in all that programs we were taking the data from the keyboard, getting stored in the variables. Program was processing the variable, producing the result. The result was also kept in the primary memory in the form of variables, and then those variables value was sent to the monitor as a output. But that data which is getting stored in the primary memory is till the program doesn't terminate. The moment program terminate, the data is lost. But our requirement is we should be able to preserve the data, okay, and we should be able to process any huge amount of data. Okay, so as your primary memory size limitation is there, so you cannot process data more than that. Getting? And your data is getting lost. So we want to preserve the data, and we want to process large amount of data, and that is only possible by going to some secondary storage. Correct? And then there are different types of secondary storages. In some case it is in magnetic form, in some case it is in optic form. Clear? Different forms of energy are there. Getting? So you have CD and hard disk and flash drive and so many. Okay? So I'll not go into the technicality how the information is getting recorded on it. Just remember, on this secondary storage, blocks are reserved, and to that block some logical name is given. In that block you will store the data, you will retrieve the data, and the speciality is that the data which is there in these blocks cannot be destroyed. It preserves for any time, and you can store very huge amount of data over here, irrespective of the size of your primary memory. Correct? Now, how to deal with these files in Python? So for that there are functions, but before that just the quick prerequisite just I'll tell you, or maybe you know it, just I have to recall it. Now always remember, whenever you are dealing with the file, okay, whichever is kept on the disk, right? Now we'll assume this is the file on the disk, and this is the program in memory which is going to process this file, or vice versa, creating file. On the disk I have to create a file, and in that I want to store the data. Program want to store the data, or program want to read the data. So whenever this file are present on the disk, or you're going to create it later, or it's present already, program doesn't directly deal with the disk. It can do, but there are many reasons for which they are not allowing. Means your operating system is designed in such a way that it doesn't allow your program to deal with the file on the disk directly. It is never possible. Okay? Means it can do it, but the system is designed in such a way. The program is not given direct access to your file on the disk. Rather, some buffers are created in memory. They are called as system buffers. Okay? So always remember, whenever you are saying that you are opening a file, when you are opening a file, that time this actual thing happens, that in the memory some system buffers are established. This is your primary memory. Then the data from the file comes into primary memory, and your program accesses from that primary memory. Means never your program reads the data directly from the file. Program is not given direct access to the disk on the file. Rather, your operating system is designed in such a way that internally some kernel buffers are established. The file content from the disk come into this buffer, and your program reads the value from the buffer. Same is the case when you want to write something into the file. The program doesn't directly write on the disk. Rather, some buffers are created, buffers established. Then your program, whatever is sending or whatever is trying to write into the file, is first actually stored in this buffer. And when you say you're closing the file, so when you close the file, that time the content of this disk, this buffer, is at a time stored into the disk, and then these buffers are freed. Getting or no? Clear? So always remember, whenever you say you're opening a file, when you're saying you're opening a file, means actually what is internally getting established, the buffers, okay, and the content of the file is coming in the buffer, and your program gets access to the buffer, again that through in the form of a object, because Python is a object oriented programming. Same is the case in Java also. Same is the case in C++. you'll get an abstraction. This object is an abstraction between your program and the file. Means this object hides lot of low level details from you people. When a programmer doesn't have to bother about how to do the low level reading or low level writing, everything this object will take care of. You are understanding or no? So this object acts as a interface between the file and the program. Your program just have to acquire this object and call its methods. The methods will take care of it. Getting? So lot of low level things are kept hidden from the programmer. That all things this abstraction will take care of. Same is the case again this side also. Between your program and the file, there is an object, that is this abstraction. And we will just call the methods of that abstraction. The methods will take care of how to do the writing. Getting? You don't have to bother about how to do the writing. Means that low level dealing, which we have done it, like in short, like in assembly or in Unix internals, like in low level C functions. All we people do it. Here you don't have to bother about that. All functionality is already being implemented by that object. Your work is just to call the methods of that object. Correct? So first point, always remember, whenever any program wants to deal with the file, never that program is given access to the file on the disk directly. Always some buffers are established and the content of the file come to the buffer, and then you get some abstraction for that buffer, that is you will get some object, and using that object methods you will read the data. Same way when the program wants to write into the file, again when you open it, the buffer is established, you get an abstraction between your program and that file, that object. Call the methods of that object, and that methods will take care of how to write the data from program to buffer and then buffer to disk. Get it? So always remember that never program is having direct access. Now there are some reasons why they might have done like that. Getting any guesses? Why do you think why the program is not given direct access to file? Any guesses? Same is the concept in C file handling, same is the concept in Java file handling.
Direct access to memory not allowed.
So why they might have done like that, direct access?
Because memory leakage issue.
But that is direct access of main memory. My question is, why program is not given access to the disk directly?
Yes.
This thing. Here though obviously the buffers are created, and then like in our societies also there are tanks created. Like corporation sends water, but whatever water supply corporation gave, is that supply directly going to each flat? Like there can be 11th floor flat, so whatever supply is coming from corporation, can it be directly given to 11th floor? Ideally not possible. That's the reason they create tanks, and then whatever supply come from corporation, it is first kept in the tank, and then through the motor, some step up motor will be there, which will move your water up to some upper tank, and then it is sent to the flats. So there is a buffer created, isn't it, between PCMC supply and the flats. PCMC supply is not directly given to the flats. ideally, which is not possible. It won't reach also to 11th floor and 12th floor. So they have created such buffers. Same way, like if you are driving a vehicle, two-wheeler, so there are shock observers. Yes or no? That spiral shock observers are there. Why that shock observers are there? Like whenever your vehicle goes in some road holes, like are there, getting, or it goes from some speed breaker and all. Okay, so it protects your spines and all. No, your body spines are not coming directly in contact with that pressure. So there are this speed, you can say, shock observers given to your vehicle. Or even in your body also, bone and skin, there is a muscle between it. God creation only. Getting, some people have more muscles, some have less muscle, whatever. So if someone's direct contact come, someone is trying to hit you, so if the direct contact come to the bone, so it may damage bone. That's the God's creation. There is a protection between the skin and the bone. There are muscles in between. So in short, just what a medical, automobile, real life, all examples I tried to give you. The buffer mechanism. Why your program might have not been given direct access, which they can do it. The program can directly access the disk. Program can do it. Okay, low level assembly calls you can give. We have done it. We have done it in 8086 assembly. Through proper interrupts we used to generate and directly write it on the disk block. Directly read from the disk block without using this buffering. But why the operating system is designed in such a way that they are not giving direct access to your file on the disk? No idea.
That disk is being used by lots of programs, lots of things. So it might
Okay.
get, if we are reading the data directly from the disk, it might get affected.
Okay.
Yes.
Okay. You can say like that. One reason you want to say, if simultaneously on the same file, many programs, many programs are doing simultaneously operation on it.
Yeah.
Getting? It may happen, right? Means the same file someone has opened, the same file one more has opened. Simultaneously, if there are many people trying to do the work, getting? So there can be a race condition. Means the data inconsistency can be there. So
Yeah.
let everyone get their own copy in their memory. Getting? Means everyone will get. Now this is one who is dealing that file. So he'll get his own copy in the memory. Someone else, they will have their copy in the buffer. They'll have their own copy in the buffer. Getting? Which you can try in Notepad and also. Try to open the same file many times. Same file. Then what happens is the file which you save last will get saved. Clear? That is called as race condition. So if suppose many are trying to do the operation on that file, the data may get inconsistent. One program, second program, third program, and all are doing operations on it. Getting? That is actually called as acid property. That is atomicity, consistency, isolation, durability. Clear? So the same file, if many program try to access, the data in this can become inconsistent. So let everyone get their copy. Everyone will do the work on their copy, and when the work is over, they'll save it. So whichever copy is saved last is the final result. Get it? So that is one reason. And another reason is, which here I gave an example of corporation supply and all. The another reason is that this secondary storage is an electromechanical device. As it's an electromechanical device, its speed is not like your semiconductors. Main memory, Your main memory in which you are creating buffers. Main memory is made up of very high speed logic. The speed of reading writing is not the same as that of reading writing of the disk. Means tremendously, means more than 17 times faster. Who is there? Your main memory comparative to secondary. So speed match doesn't happen. The speed matching is not taking place, and therefore as it is synchronously, it cannot be done. Like one data read, next data read, one is to one will happen. So the whole process will become slower, and that's the reason intermediate buffers are there. So you will write according to your speed in the buffer, and it will save it with its speed in the buffer. Same way, the data will come according to its speed, and you will read it according to your speed. Means the speed matching need not be done. You don't have to bother about your program speed and the IO speed. Okay, as there are intermediate buffer, it will keep reading and storing it in the buffer. The same example here I told, the speed by which the corporation give and the speed by which you can give it to the individual flat cannot be matched. Therefore, let it come by its speed. We will accumulate it in the buffer, and then through step up, we will move it to the upper tank and then give it to the flat slave. You understanding or no? Clear? So, in short, why buffers are there? The two reasons. One, for speed matching between the two different storage medias. This is a primary memory, this is secondary memory. So speed matching, and second is for making the same file available to multiple users. If suppose many programs want to use the same file, okay, they all are not doing process on the same file on the disk. They will have their own copy, and when their work is done, they will save it. Whoever saves last, that data will be the persistent data. That will be the final data. Clear? So I hope you are understanding it. Is it right, all of you? Now these all concepts actually, like if you have studied operating system and all, if in your life somewhere operating system is studied, or advanced operating system like Unix internals and all, so in that all these concepts are more clear to you. Anyways, now we will start dealing with files in Python. Now how to deal with files in Python? So for that, very simple functions are given. When Python has made file handling very simple, not too complicated. Correct? So before starting reading from the file or writing into the file, okay, you have to first open the file. When we say we are opening the file, means actually what is getting established? Many books mention it like just opening a file means open the file. Clear? So opening the file means actually internally what is happening. So always remember what is happening. Buffers are getting established for your file. Okay, for writing purpose also or for reading purpose. What are getting established? Buffers. And you'll get an abstraction between that buffer and your program. Abstraction means you got it, no? Abstraction means you'll get what? An object of a respective class. And then the methods of that object you'll use for reading or for writing. That object will take care of how to read or how to write. Your job is in the program, just call the methods of that object for reading, for writing. Clear? So for doing all that operations, you just have to call the methods. You don't have to do low level dealing. That all things that methods will do. So abstraction means it's an object which acts as an interface between the file and the program, and program and the file. Just remember that object acts as an interface, meaning it acts as an abstraction between your program and the file or file and the program. Meaning your program doesn't have to deal with the low level handling. Who will take care of it? This object method. So object dot method. For writing there are method, for reading there are method. Just you have to call that methods. Is it clear to you or no what I'm saying? Yes or no, guys?
Yes, sir.
Okay.
Yes, yes.
Means actually when you're opening the file, so means in reality what is happening in the background? When you're opening the file, what is actually happening? Can anyone justify?
Buffer is created.
Yes, buffers are established. Then the data, if you're reading it, if you're opening it for reading purpose, then the content of the file will come in the buffer. And if you're opening it for writing, the empty buffers are created. And later you will start writing. So whatever you'll write, that is written first in the buffer, remember. And when you actually close the file, that time the content of the buffer is copied to the disk. Getting clear? So when you are actually closing, that time the buffers are saved on the disk, right? So when you're opening the file means actually the buffers are established. And do we get some abstraction for that buffer? Abstraction means what do you get? An object. And is that object going to make all your work hidden? Yes or no?
Yes.
Clear?
We can use the methods in it. Directly it
Yes.
will work.
Yes, yes, means you got it. The concept is clear. You just have to call them methods, and that methods have taken care of how to deal at the low level. Getting or no? So, lot of low level handling from us, from the programmer, is being done already by that methods. Your job is just to acquire that object and then later call the methods. Methods for reading, methods for writing. Okay. But actually, how the low level writing and low level reading is happening, that is everything made abstract to us by that methods. And that's the reason I said it's an abstraction between the file program file. Okay. So, hope it is clear to you. So, first we'll see how to open a file, right? So for that there is a built-in function. This is not a method, this is a built-in function. Lot of built-in functions we have discussed, isn't it? From so many past chapters we have done. We started our Python journey only with first built-in function called print, then input, right? Then type, then id, then isInstance, and then so many more. Getting on? No? Then many we saw: oct, bin, hex, chr, ord, then map, filter. So many methods we have seen. Built-in functions. The exact same is open. But open is a built-in function, but it will return you one file object. And once we get the file object, afterwards you have to call the methods of that file object for reading, for writing, for closing, for rewinding, for everything the methods are there. But that methods are of that file object. And who will give you that file object? This open. Okay. So open is a built-in function. So opens file with the given file name and with the given mode. You even have to tell the mode in which you want to open the file. So mode is given, the name of the file is given. If that file is successfully opened in that mode, then you'll get one file object. Preserve that file object for all next operations. That is for reading, for writing, for closing, for all the activities we have to use this file object. Okay, I hope it is clear. Now quickly we'll discuss the syntax: open, name of the file, and then the mode. Okay. Now file name means the name of the file which you want to open for reading or for writing or whatever. The name of the file. But this file name you can give by two ways. One, that is by relative path, and another is absolute path. Getting? Means if your path begins with the drive name, or if it is in Linux, if it starts with slash. If you have experience of using any open source operating system, any open source operating, Red Hat, Fedora, even Unix is not open source, but Linux and Fedora and Mandriva and all those Open Solaris, SUSE and so many other, Ubuntu, CentOS, all these are derivatives of Linux, and they all are derived from Unix operating system. Getting? But Unix is not free, but these all are free. So in that file system, we give the path by starting with slash. If it starts with slash, it is absolute path. Means it is starting from the root. Getting? Slash ABC, slash PQR. Getting or no? And then the name of the file, a.txt, whatever. Getting? So if your path is beginning with slash, it's called as absolute. So the searching will begin from the root of your system, your file system root. But if it doesn't begin with slash, it is relative. Getting? Like I have written abc slash pqr slash a.txt. So if the path doesn't begin with slash, then it is relative. So relative meaning it will search the file, okay, in this whole path, but this path will begin from the current directory. Currently wherever you are, in that directory it will search ABC, and then inside that PQR and inside that file. Not from the root. The searching won't begin from the root. The search will begin from current directory. Getting or no? Clear? Same technique is in Windows also. Only the case is in Windows the drive name start. So if your path begins with such drive, C:, front slash, backslash, both allowed. ABC, PQR, and then file name. So the file is searched starting from the root, that is from the C drive. Inside C drive, it will search for ABC, then PQR, and then this thing. And in Windows based system also, if your path doesn't begin with, slash, with drive name, that is C:, D:, whatever, so it is relative. So it will search where? In the current working directory. So whatever is your current working directory, inside that it will search this folder and then further. So the search will start now from current working directory, not from the root. Okay, so that concept is clear. And then there are different modes of your file. Okay, what are the different modes? I'll discuss all that one by one. Before that, about this file name. So see, the file name path can be relative. Now relative means always the searching starts from the root or from the current working directory. So current working directory. How to recognize it's a relative path? So how do we recognize it is a relative path in Windows based system? If it doesn't start with your drive name, C:, D:, if it's not starting with that, so always it is current. And if it starts with drive name, so it is absolute. That is beginning from the root. Okay, I hope you got it. Then what are different modes for opening the file? But if the file is successfully opened, this given file name is opened in the given mode successfully, it will return you one object of the class file. Getting or no? It returns a file object. Right? So what are the different modes for opening a file? Quickly I'll just explain first and then all the modes we'll see. Okay? But I hope you are clear to you. If the file is opened successfully, then you are going to get one file object. Okay? And that file object's methods you have to use. You have to use the methods of that file object. Okay? So different methods are there for reading, writing, rewinding, closing, all that. Now quickly we'll discuss about the modes. First mode is read mode. Okay, So read mode means you're opening the file for reading. Now in case of read mode, the file has to exist. Okay, the file which you are opening has to exist. If it doesn't exist, it will throw an exception called file not found error. File not found error is thrown, exception is thrown if the file doesn't exist, because you're opening it for reading. For reading, the file has to exist. So if it doesn't exist, it will throw error. And if it exists, okay, so the pointer will be always at the beginning. Now in that buffer also, now previously I have drawn that buffer and all. From the disk, the file comes in the buffer. So internally one pointer is maintained, which tells you the current position from where the reading or writing is going on. Where the writing or from where the reading is going on is indicated by one position, and that position is called as a file pointer. Getting? And that file pointer keeps updating. As you go on reading or go on writing, the pointer updates. Right? Okay. So that file pointer is always at the beginning in the case of reading. Okay. And as you go on reading, the pointer will go on advancing. Okay. So in case of read, what is the speciality? File has to exist. If it doesn't exist, it will throw file not found error. And if the file exists, then it is successfully opened and the pointer is where? At the beginning. Okay. Then we have other mode called write mode. Okay. Now writing means you are opening the file for storing something in it. Writing. Now in case of write mode, if the file doesn't exist, it will create it. And if it exists, the old data is going to get erased. Means whatever the old data is there in the file is going to get overwritten with the new data. Getting? So here, this is your file. This is the buffer. Okay, this is your program. When you're opening the file for writing, okay, the empty buffers are created. You will go on writing data within the buffer. When you close the file, the content from the buffer is saved in the disk. But if suppose there is a file with that name already existing, obviously the data is overwritten. Means the old data is lost and new data is overwritten. Okay, and if the file doesn't exist, it's obviously going to create it. Okay, so hope about writing is clear to you. Then we have append mode. By the name append, you know it. Okay, it will write the new data at the end. Okay, so when you're opening the file for appending, file doesn't exist, it will create, no doubt, like write. But if it exists, the data is not overwritten, means the old data is not lost. The new data is put at the end of the file. Get it? Means the new data is attached at the end, that is appended. Okay, I hope you got it. And with all this, you can attach plus sign also. So R plus means you're opening for reading as well as writing. Reading also and writing also, but file has to exist. Writing plus reading also is there, W plus. Writing as well as reading. But if the file doesn't exist, create it. You know it. Append plus is also there. That is append as well as reading. Okay. And if you are attaching to all this T, then it will treat as a text file. And if you attach B to it, it will consider it as binary. But not attaching T is also by default text file only. So by default, it considers the file as text file. But if you want to tell that it's a binary file, then you have to attach B to it. Getting clear? And the last one more is there, that is exclusive, X, which you have to attach with this, any of this. Any of this, if you combine it, so it will modify the behavior. Like, see, in case of writing, okay, if the file already exists, so what happens in case of writing? If you're opening the file for writing and if the file already exists, so the data is truncated, data is lost, and the new data is overwritten on it. So I want that if the file already exists, then this writing mode only should fail. Means it should not create only file and overwrite this new data if the file already exists. Means it should create it only when the file doesn't exist. Then you can use this X exclusively with W. Getting? So if with W, if you attach X, so it is write exclusive. Write exclusive means open the file for writing only if it is exclusively, when it is not existing. Getting? So when the file doesn't exist, then open it for writing. But if the file exists, then please don't truncate the data. Getting? Which you normally do also, na? Many times, like when you go to save some file, and if the file with that name already exists, so it asks you, na, replace yes or no. Same mechanism if you want through program. Getting? So you want that if the file already exists, it should fail. If it doesn't exist, then only it should create it. Getting or no? So for that, exclusive mode. Okay? So all these different modes are being provided. So R is for read, which is default. When you don't give mode, it is by default read mode. Opens the file for reading. If the file doesn't exist, exception is thrown. Append, okay, it will create the file if it doesn't exist, but if it exists, the data is not lost. The pointer is at the end, and therefore the new data is put at the end. W, write, open for writing, file doesn't exist, create it. Creates the file if it doesn't exist. But if it exists, the old data is sure going to get lost. It will truncate and write the new data. Exclusive creates the specified file, returns an error if it exists. So if X I attach to W, WX. Okay, so it will open the file for writing, but exclusive writing. Meaning it should open for writing only when the file doesn't exist. If it exists, so in case of W, what is happening? If it exists, it erases the data. But if you attach X, then in that case, if it exists, it will give a error. It won't truncate the data. Opening only will fail. And you want to tell the file is a text file. T, if you want to tell it is binary, and plus sign also you can attach. So R plus means read write, append read, write read. Okay, so it forms that combination. Examples I have given. In the first case, the path begins with drive. So as it begins with drive, it is which path? Relative path or absolute path?
Absolute.
As it is beginning with a drive. So it will start searching from the root. And second case, as it is not beginning with drive, as it is not beginning with drive, it is
Relative.
relative. So from where it will do the searching?
From the current location.
Current directory, wherever you are. Okay? And if in both cases the files are opened successfully, so you know internally buffers are established, and then you'll get an abstraction between your program and the buffer. And who is that abstraction? This object, this file object. Getting clear?
Yes.
Okay. quickly just example I'll give you, and then we will discuss how to do reading, writing. Very simple functions are given. See, F open. Your basic Python folder is any file, like suppose cla.py. Now this file will be opened for reading. It's only open. F open is from C. Now this is by default reading. You can check its type also. See, type of F1. It will show that it's object of class, some text IO wrapper and all. It will show. See, it's the object of class text IO wrapper, which is in this module underscore IO. Okay? Even that object, if you print, it will call its dunder method, isn't it? Double underscore str, in which it will show some information what is there in that object. See, information like it's an object of this class, then whatever file name you pass, that name only is stored in this object in name property. Mode is stored in mode property. Encoding algorithm, which is the encoding policy, so that name is given. Get it? You can open the file for writing as well. Okay, F2 equal to open this is for writing. Okay? See, the first case opens file for reading, path given is absolute, open fails if the file doesn't exist. If you want, you can check also. We'll try to open some file. Now this a.txt. A.txt, I'm trying to open it for reading. No, but now it is created. No? Okay, I'll give a.txt instead of that a.c suppose. So you can see now a.c doesn't exist, and as the mode is not given, so what is the by default mode? By default mode is reading. So as the default mode is reading, this file doesn't exist, so it will throw an exception, file not found, error. Agreed? In the second case, open file for writing, right? And path given is relative. It's not an absolute path. And if this file doesn't exist, obviously it will create it. Okay, so if it doesn't exist, it will create. And if it exists, then it will just overwrite the new data on the old data. Whatever the old data is going to get truncated, and the new data will be overwritten on it. Agreed? Then next is close, but close is a method. Close is not a built-in function. It's a method of that file object, this text IO wrapper. Getting or no? Clear? So it is a method, and when we say you're closing the file, many books mention closes the file. Actually, when you're closing the file means in reality what is happening? The content of the buffer is getting saved on the disk. That is the activity happening when you close the file. So when you are really closing the file, so whatever is the content in the buffer gets persistent on the disk. The buffer content is transferred to the disk. It gets saved on the disk. Is it right? and whatever resources were made available to your file, they all are released. Resources means those buffers which were created, that buffers are all released. Okay, so I hope you are understanding. Very simple function, but it's a method. See, so closes an opened file. Syntax is like this: file object dot close, and this is that file object which you have prior successfully acquired using open built-in function. So open built-in function has given you one file object, that file object dot close. Okay, so in some cases, due to buffering, changes made to a file may not reflect in disk until you close the file. That is the speciality. So closing does that work. Closing the file actually transfers the content of the buffer to the disk. It makes the buffers persistent. Persistent means you got it. It makes the buffers persistent means it transfers the content of the buffer to the disk. And after transferring the content buffer to the disk, the buffers are released, means the resources are released. Getting? See. So normally first you open the file, you get a file object. Meanwhile, you do some work on it, like reading, rewinding, whatever. And once the work is done, at the end, you're going to call f.close. So when you call f.close, the buffer which is associated with it, getting with that abstraction, that f is abstraction between the buffer and the program. So whatever buffer is associated with this file object, the content is first transferred to the disk and then the buffers are released. Getting or no? Clear? So is open, are open and close methods clear to you? So that next we'll see how to do reading from the file.
Yes, clear.
Okay. Then moving on to read method. Now read is for reading the content from that buffer in your program variable. Now already you have opened the file. So is the content from the disk come into the buffer? Yes. Now you have got an abstraction for that buffer, that is file object. Use this file object's read method. It will read the content from the buffer into your program variable. And after it comes in program variable, you can send it to the monitor or wherever you want. That is your choice. Okay? Now what all parameters are there to read, that I'll give you. Okay? See, reads the specified number of bytes. So here you have to give the size. Okay, so if you give the size to it, it will read only that many number of bytes. And after reading that many bytes, it will return it as a string. That many bytes are read, so it will return you a string with that size. And the pointer is advanced. Pointer is advanced by that size. And if you don't give size to it, okay, so it will read the entire file at a time. So default is -1, which means the whole file. Okay, syntax, file object dot read, and you pass the size. If you don't give size, it is going to read the whole file at a time. Okay, and if you give size, so it's going to read. Guys, just excuse me for 2 minutes. हॅलो, हां मोन. हो, चालू आहे. नाही काय इमर्जन्सी असेल सांग मला काही. तर ते ती गेल्या गेल्या ती करणार आहे म्हणाली. ती डॉक्टर काय म्हणाली, सकाळ सकाळ मी जेव्हा जाईन ना तेव्हा पहिलं जाऊन तेच इन्क्वायरी करेन आणि तिथे झाल्या लगेच तुम्हाला सांगेन. म्हणजे हां. ओके ओके. अच्छा, मग तू म्हणजे हॉस्पिटलला गेला होता रात्री परत? ओके. हो हो हो. नाही, मी तर कॉन्स्टंटली ते चेकमध्ये आहे की डीवायलाच करूया आपण शिफ्ट. हो हो हो. नाही ना, ती डॉक्टर काय म्हणाले, मी सकाळ सकाळ गेल्या गेल्या पहिलं जाऊन ते तुम्हाला लगेच इन्फॉर्म करते. हां. आता जाईल सकाळची ती. सकाळचं काही 9ला असेल तिची ड्युटी. मी परत एकदा फॉलोअप घेतो ना. हां, नक्की नक्की. हो हो हो. नाही नाही. नाही नाही, मला कळतंय ते, मला समजलं. ठीक आहे ठीक आहे, करूया आपण. हां, मी लगेच फॉलोअप घेतो. हां. ओके, सॉरी फॉर इंटरप्शन. तो रीडिंग, you got it. Whatever size you give, that many bytes it will read, the pointer will advance. If you don't give size, the entire content is read. Okay. See, first before that, what we'll do, we'll create one file, or we can read the content from our files. Like already we have opened file cla.py. Now, if I write print f1 dot read and suppose I give 10, so it will read only first 10 bytes. See, in that file, the first 10 bytes were this thing, import sys. Now, if I write read and I'm not passing anything, so already the file pointer is advanced by 10 bytes. When 10 characters ahead it has come. Now when I write f1.read, so from that point till the end of the file, everything is read. See, whatever the content was there in the file, I hope you remember yesterday or day before yesterday we created this file. So the entire content of that file is displayed. Clear? Okay. Hope it is clear to you. See, for example, what will assume that in this path, this sample.txt file is created. Sample.txt file is existing. Okay, we'll assume sample.txt, this is the file. Now you have opened that file for reading and you have got this file object. Okay, so this is the file which you have opened for reading. You got a file object. Now you are writing f.read. So as the size is not given, it is going to read the whole file content. Same file I am opening for reading, but here I am writing f.read 12. So it will only read 12 characters. See, so whatever 12 characters were formed, that 12 characters it will display. Getting clear? I hope you're understanding. Right? All of you?
Yes.
Sure, na? Others also, please. Akshay. ठीक है. Then Avanti many times remain absent. I don't know what the issue.
Yeah, she has meetings in early morning because of she work as a team lead and her team is working in two shifts.
Okay.
So
She's
that's why
senior to you.
no, just her team is different.
Okay.
So she's working as a team lead in that team.
Okay.
So her team is working in a two shift and she has a meeting. She has to attend meetings for the two shifts
Okay.
sometimes.
Okay. Next method we'll discuss, that is read line. Now read line is also the method of अरे दरवाजा काय उघडा टाक. Okay, read line. Now to read line method is basically for reading one by one line. Okay, but here also you can give size. But if you give size, so it will read that many characters or a line, whichever occurs first. Getting? Whichever occurs first means what? I'll just try to diagrammatically tell you. Now, one line is containing some data. Now, to that read line, you have given some size, suppose. Okay, 10. So, if your line is not getting over before 10, so it will read 10 only. Getting? But if the line is over before 10, so it will read only the line, whichever occurs first. Means the number of bytes occur first, so at that it will stop. And if the line ends first, so it will stop at end of the line. You understanding or no? Means suppose this is whole line with 45 characters, and here I wrote 100. Getting? I have given 100, but you have your line contains only 45 characters. So your end of the line is coming before 100 only. So it will stop at end of the line only. Okay, it will stop at end of the line only. So whichever occurs first, as I said. If the line ends first before the size, whatever size you have given, and before that only if the line ends, it will stop at end of the line. And if the line ends later before the size, so it will stop at size. Getting? So read line is basically for reading one by one line at a time. To read one line at a time, for that basically read line is made. But generally for read line you have to give the highest size of the line. Getting? Means give the size such that your all lines are ending before that size only. Getting? If your line ends after the size, so it will read only that size. So as I said, like this line was containing 45 characters and you gave 100. So it will stop at 45 only because line is ended before. But suppose your line contains 120 characters, so it will stop at 100 only. Whichever occurs first. Size occurs first at size. End of the line occurs first, end of the line. Okay? So that way the technique is. So returns one line at a time from the file. So whenever you want to do line by line reading, generally preferred one is read line. Okay? Then size indicates how many bytes to read from one line. Okay? Default is -1, which means the whole line. And whenever you don't give any read line, you don't give any size. So it is by default going to read one line at a time. But if you give size, so as I said, whichever occurs first, end of the line occurs first, so it will stop at end of the line. If size occurs first, so it will stop at size. Getting? Syntax like this: file object dot read line and then give size. Okay? See, just an example we can take. Sorry. What I'll do is I'll create some file. Okay, some lines will write. Okay, I'll close this. Now here we will open that file. I created sample.txt. Read mode is not necessary. Okay. Now in a while loop also you can read it. Means you can keep reading the lines in the while loop also. Correct? One by one. Or in a for loop also it is possible. Okay. I read line and then just keep printing that line. Okay. So now if I write print f dot read line, it reads one line. Suppose I continue again, so it will read the next line. Okay, if I continue again, next line, right? And if you give size, see, it reads only that. So as I said, now whichever occurs first, if size occurs first, size. If end of the line occurs first, end of the line. Getting? And now if I don't give size, the remaining line it will read. Clear? Okay. See. The same file I have opened. Right? Open. This is your file for read mode. F dot read line, one line it will read. Again, if I continue, one more line it will read. If you give the size, so only that many characters it will read. So as I said, now whichever occurs first, if the size occur first, size. If end of the line occurs first, end of the line. Right? Okay. Then next is read lines. Okay. Now if you want to read all the lines from the file at a time, now you may say then read also does the same thing. But here it will return you as a list. Read also reads the entire file. Okay, read function that we have discussed now. So when we use read and we don't give any size, so it will read the entire file. Now this read lines will read the entire file, but it will return you each line as one item in a list, and it will return you a list of lines. Means one item in the list is one line, second item in the list is second line, that way. So it reads all the lines from the file. All the lines from the file are read, but all that lines it returns as a list of items, and each item corresponds to what? One line. Clear? Returns a list containing each line in the file as a list item. Okay, so only the difference is what here it will read all the lines, but it will not return you one single string like read. It will return you each line as one item, and as many lines, that many items in one list, and one single list is returned. Okay, and later you can traverse that list, right? So returns a list containing each line in the file as a list. If the total number of bytes, whatever lines it has returned, okay, if the total number of bytes returned exceeds the size, no more lines are returned. You understanding? So here also you can give size, but within that size, how many lines are accommodated, only that lines are returned. Getting? Like to read lines, suppose I give 100. So till 100, as many lines are accommodated. Getting? Like suppose first, second, third, fourth. On fourth line, 100 is getting over. So that line incomplete it won't show. That line it will return complete. But after that, next line it won't return. Because at size 100, 4 lines are over. So now next lines are not sent. And when you don't give size, so all lines are returned. Clear? See, default is -1, which means all the lines will be returned. Syntax, file object dot read lines and then size. Okay? See, for this example we'll give. I'm opening the file. I'm printing f dot read lines. I'm not passing the size. So all the lines are read as a list. See. Getting? You could have used it in a for loop also. See, like this. For s in f dot read lines. Okay? And here, if I write print s, it will display each line one by one. See. Because f dot readline has already returned you what? A list. And I hope you know it. In a for loop, what we can use. In a for loop, what we can use? A iterable object. Clear? And list returns you what? And list is a what? A iterable object. So f dot readlines returns what? A list. And is list a iterable object? Yes. Clear? So you can use that iterable object in a for loop. So one by one lines you are fetching in S and you are printing it. Getting? Now Python says you can use directly that f object as a iterable object. See, if you write for S in f is also valid. You understanding? See, still the lines are printed. So why? Because here implicitly that read lines is called. Irrespective, if you don't write, then also here that read lines is called and it will keep returning you one by one line from that file. Getting? So that is also possible. Should know that. See here. Now if you give size, so how many lines are accommodated in that size? Only that many lines it will return. Getting? So as I have given 3, so in size 3 only one line is getting covered. So only that one line. Getting or no? Clear? If I write f dot read lines and I am giving 10. Okay? So till 10, as many lines are covered. Suppose I'll give 25. So till 25, how many lines are accommodated? It will return. But it will not return incomplete line. Like if 25 is getting completed in second line somewhere in between. So that line is not returned incomplete. That line it will complete and after that no more lines. See. Getting? First line and second. Actually 25 might be getting completed somewhere in between only. But that line it completes and then stop. It doesn't return more than that. Okay? Okay. So hope it is clear to you.